Hi, Jimin. Welcome back.
Hi, Robin.
Right, so we're looking at BlazerOps.
Yes. So this is BlazerOps. Essentially, it's a developer-facing tool for people to be able to create spatial machine learning models at a really accelerated pace. And so we know that it takes quite a long time to build out the data pipelines, to have machine learning training ready data sets, and then also quite a long time to be able to iteratively create machine learning models. And our platform is essentially there to help machine learning developers and analysts really rapidly iterate and build production grade spatial machine learning models.
Hmm.
Right. So I'll just sign in and give you a quick walkthrough of what this platform looks like in action.
Hmm.
But before I go any further, maybe I can just begin by providing some context on a data set that I'll be walking you through that we built a machine learning model with BlazerOps. So essentially, EuroSAT released a data set not long ago. Essentially, it's a file that contains 13-band Sentinel-2 imagery, and this is a total of 27,000 labeled and georeferenced images. And essentially, this labeled machine learning ready dataset is the dataset that we used in our example today to allow the spatial agents in the BlazerOps platform to autonomously create a machine learning model from scratch. And so we know that the benchmark R square that this model, the CNN model based on this data, was 98.57. And so we took the same data set and we allowed BlazerOps spatial agents to create a machine learning model with no other details than, hey, go look at the data and create a machine learning model
Mm.
based on the prompt. And so in this example, we deliberately did not steer the agents and we let the agents go off and inspect the data as well as our prompt to independently arrive at a machine learning model. So I'll just walk you through. To begin with, this is the main tasks page. This is where everyone lands. And here you can see 4 different machine learning projects. And creating a new project is as simple as saying new task, inserting the task name, and then in plain language describing what the spatial agents should build. And so, for example, if you are a insurance provider, you could be interested in creating, let's say, a urban fire risk contagion model. So you would just put in urban, um, and then you could just describe in plain language, uh, no, incorporate shielded assets such as green areas and car parks to account for shielding and integrate the additional wind data provided. And like that, you would be able to provide the metric to optimize for. And in an instance where you're not quite sure what metric to evaluate for, you can actually leave it unchecked and the agents can build and as it builds, recommend the ideal metric or metrics for you to evaluate against.
Mm.
And then you'll be able to connect or upload your data set. So currently on the platform, the alpha is live, and so you're able to upload up to 10 gigabytes of data sets to start training machine learning models today. Um, or you can choose to connect to your, let's say, your S3 bucket or your cloud provider storage space. And if you want to go beyond the 10 gigabyte limit, then you can reach out to us for a design partnership.
Mhm.
But anyway, this is how you can create a new task. It's a very simple and intuitive process. And once you create new task, you will start having the spatial agents query your data and actually independently start forming experiments. Now, in this case, this is linking back to the EuroSAT data that I showed you earlier. Now, here we can see when we inspect the data that indeed the EuroSAT data is uploaded. So the EuroSAT data set totals around 4 gigabytes. So we uploaded that, and now it's all connected to the platform for the agents to be able to inspect. And so I'll take you through the first experiment to begin with. You can see that in every experiment space, you have an independent hypothesis that the agents form. So you have the overall coordinating agent that will inspect your data, will inspect your research objective, and it forms a hypothesis. And so here it says transfer learning from ImageNet pre-trained ResNet 18 will achieve strong baseline accuracy on EuroSAT land use classification with minimal training. And so it's gone off and it's in its allocated sandbox space. It's actually created the training script here and it's trained this experiment. And you can also see that in this case, it arrived at a postmortem where it didn't quite work out. And this does happen in the initial stages, where the agents are just figuring out how the data is configured and it's kind of figuring out all of the kind of variables. But once it does that, it's able to then arrive at an experiment with a pretty decent R-square value. And so here, by experiment number 6, it formed a hypothesis that providing a complete template code with a lightweight custom CNN and data subsampling will complete training quickly on CPU and achieve greater than 60% accuracy on EuroSAT. So it formed this hypothesis and it's also learned iteratively from every other experiment run. And success, it arrived at a accuracy R-square of 0.7260 and a training accuracy of 0.713. And postmortem indeed reflects this. It says first successful training completion after 5 failed attempts. And you can see that the agents have not only formed a hypothesis to get the high R square, but it's also looking at how much compute resources you're using, and it's trying to find the most computationally efficient pathway as well. And so you can see in the middle panel training progress, as well as all the other metrics to be able to evaluate your machine learning model. And you're able to look for and evaluate against all of the metrics that are important to you as the machine learning engineer. And then you can also look on your right side, the resource utilization column, where you can see and keep track of the token burn, as well as CPU, GPU, and RAM. And then at the bottom, although we're just quite in the compacted screen, you'd actually be able to see your training script. And so you would actually be able to export this and run this in your coding IDE, and you'd be able to achieve the same results. And so the agents continue their journey of evaluating, creating independent hypotheses, and then trying to eke out the highest possible R square. And once it reaches a local maxima, then it will decide. So that's set at a threshold, but it is adjustable of around 8 repeat experiments. So once it reaches a plateau in a certain architectural neighborhood, it'll make a decision to try out another architectural choice and to then start seeing if we can get a higher R square or higher evaluation metric through that approach. And so it's jumping from one architectural neighborhood to the next, trying to continuously improve the performance and robustness of the machine learning model. And it continues to do this. We can see that by experiment number 14, it's getting quite close. It's reaching an accuracy of 0.89 after 10 epochs. And you can see here it's got its independent hypothesis as well as the postmortem and then the training script for this particular experiment as well. And after this, we have, we did interrupt this manually for stopping this in preparation for today, but the highest experiment, the highest R squared that we had until we stopped it was at experiment 17. After 15 epochs, we had 0.8963 accuracy. And let's see the hypothesis here. ResNet 18 with Mixup regularization, alpha at 0.2, one cycle LR, and label smoothing for 15 epochs on 1500 class will exceed 89% on EuroSAT. And we've got the postmortem, and it's confirmed its hypothesis. So this is essentially the idea of BlazerOps Model Incubator. You can provide a plain language prompt. You can add as much or as little detail as you would like. You can add supplementary resources and link research papers if you'd like it to try replicating certain research papers. But you can be quite broad. And With those instructions, the instructions as well as the training data that you provided, the spatial agents are able to independently go off and create these machine learning models. And here you'd be able to select this particular experiment, and then you'd actually be able to, if satisfied, push it to GitHub. And if we go, we've selected experiment 17, and we can push it to GitHub. And I can see here, oh yes, I think I've already uploaded experiment 17, already exists on this. Yes, looks like the branch was already pushed. But yes, ordinarily you'd be able to push your experiments of choice to GitHub as well.
Mhm.
So it's
So I guess
designed to.
one of the
Mm,
nice benefits of this kind of platform is kind of observability and what's happened one experiment to the next. You can see the description. So does
mm.
it provide you some kind of high level summary of the path it took and why it went in certain directions?
hmm Yep. So you're able to actually get that by talking with your agents and asking it to provide you the high level summary and the journey it took in order to arrive at the highest performing machine learning model. Um, we've disabled that for now as we're pushing a new update as it's pushed to prod Wednesday. So that I won't touch that for today, but you're able to communicate with your agents through this communication panel on the right side, and you're also able to steer your agents as well. So it really is a tool for analysts who don't have that much spatial machine learning experience to actually apply their domain expertise and create machine learning models. But it's
Mm.
also designed to be a power tool for machine learning engineers who want to have maximal control over the entire process.
Mhm.
So in this particular instance, it took a total of around little over 10 hours um, of spatial agents independently using the compute as well as the tokens to arrive at this machine learning model.
Mm.
So this is a 10-hour time that it took to create this machine learning model at the R square that it did with, fairly complex CNN architecture that was required for this. Now, um, I guess it depends. Everyone has different tools and different, expertise, and you could be doing this across a team. But I would imagine that, with the data set that we're provided, it would ordinarily, manually, take a little bit longer than 10 hours to be able to create that kind of machine learning model. Now we know that the R square for the final benchmark was, I think, 0.98, so it was a wee bit higher. But essentially, the idea is that you'd be able to continue these experiments until you arrive at a, comparable R square. Or, if you're satisfied, you can interrupt it and you can keep what experiment you're satisfied with. So
Mm.
that's in a nutshell how the platform works. Um, but maybe for a moment, I'll step back and show you some of the other features that we have as well. So in terms of what's powering this platform, it's a hybrid model. So if a user already has their own API keys, if you're already using, let's say, Anthropic's models, or if you're using ChatGPT's models, even DeepSeek R1 and NVIDIA's free models, NIM models are now usable as well. So you can actually insert your keys into the platform and use the compute key. So you can, bring your own compute. Um, but if you don't have that, then the model, our platform can provide that for users as well. And if you have your own cloud compute, then you can also bring your own compute as well. But for analysts and other individuals that aren't training and fine-tuning AI models like this, then we can also provide cloud compute as well. So it's a flexible hybrid model, again, designed so that anyone from non-technical analysts to machine learning engineers can make use of this platform.
Mhm.
Mhm. And in terms of the roadmap for where this platform is headed, right now we're in very early alpha, and kind of early developers can have access to try out the platform and provide feedback. But down the line, we have a few exciting things that are upcoming. So on the side column, you can see that we have pipelines. So pipelines is the next exciting iteration. Essentially, what that's enabling is not only the automation of machine learning model, spatial machine learning models, but it's actually allowing for the data engineering process from raw heterogeneous data to be unified into a machine learning ready training data set. And so it's actually inspecting your raw data that you provided. It recommends the transformations that you need to apply to it to make it machine learning ready, and it then architects out the pipeline. So that's, we think, very relevant because, in many instances, the bottleneck is also in the getting data ready for machine learning training in the first place. So we're quite ready and excited for that. Um,
Mm.
and then we also have WorldGrid as well, which is upcoming. Essentially, WorldGrid is a map-based interface for individuals to be able to easily visualize and overlay data that they're working with. Um, but WorldGrid is already actually working in the backend, and it's the framework that we're giving our spatial agents to be able to make sure that all the data that it's working with is spatially and correctly, aligned. So that's already working in the back end, but we hope to pull that as a visual reference for users to be able to look at and play with as well.
Mhm.
Then last but not least, you just have the cluster panel here that shows all of your job history as well as your resource utilization. And then to top it off, you've got your data management as well. So you can upload manual files, or you can connect to your cloud provider.
Mhm.
So Robin, yeah, I think that's about it. That's a whistle-stop tour of the BlazerOps Alpha platform.
Very interesting. I can see the potential and how it kind of unifies different aspects of the machine learning flow, and obviously the models are just going to get better over
Mm,
time. And what's really interesting, I suppose, is that they can just autonomously do all this kind of work and constantly stay on the task. And I think that's what those
mm,
token traces were showing, right? Is monitoring the run. If it doesn't like what it sees, it might interrupt the run, try
mm,
something different. Whereas obviously machine learning workflow, you probably won't be staying up all night watching every training run. So that's definitely
mm.
a kind of new capability
Yes.
there. And I'm curious about the integration elements as well, because
Mm,
you've built some aspects like visualizing losses, etc., that exist in other tools. Is your plan to try and bring all of those features into this one tool, or are you also going to be
mm.
connecting to other systems?
Yes. So our plan really is to bring everything into one tool, as you mentioned, for greater interoperability across the entire workflow.
Mm.
Um, and to connect to, I guess, to the earlier point that you made about, making, freeing up people's time as they're able to go off and have these agents independently, create these experiments. We think it does free up a lot of manual labor that goes into it, but at the same time, we really do imagine this tool not replacing machine learning engineers, but actually allowing machine learning engineers to be able to move much quicker. And so we believe that this has the potential to be a power tool to be able
Mm.
to more efficiently collaborate with spatial agents.
Mhm. Brilliant. Just to wrap things up, just want to finally clarify, if somebody has their own API keys for Claude or whatever, is that all they need, or do they need to sign up to the platform? Is there any other kind of overhead that they need to be aware of?
Oh no, that's all they need. So you can just sign up today. So you can access the platform via BlazerOps.ai, and then you can provide your Anthropic or ChatGPT API. But you don't even have to do that. Currently, we provide 1 million free tokens per user per day to be able to just try the platform for free. So you could even just try downloading the EuroSAT data set that I showed everyone today. You can just try downloading that, connecting it to the platform, and try it out for yourselves.
Wonderful. Okay. Well, thanks so much for giving me the tour of the platform, and all the best for the development.
Thanks, Robin. Really appreciate it.
Bye.